Oh, your integral? Okay, so the integral of u dv is going to be equal to uv minus the integral of v du. And part of what makes me feel better about going over this with you guys again today is, oh yeah, and then let's see. And then part of what's going to make this better today is a way for you guys to better choose what should be the u. And so that's what we're going to talk about today, is the order in which you should choose things to be the u. So, order in which to choose things to be u. And this is totally not mine. I stole this from someplace else. And it's like a weird acronym. It's almost late. It's L-I-A-T-E. So first, if you have an option for it to be anything logarithmic, that should be your first choice for you.
So anything that's like 1 over x?
No, like ln x. That should be your first choice.
Like ln or e to x?
Well, no, e to the x should be your last choice.
Oh. It's just e to the x.
Right, e to the x should be your last choice for you, though.
So logarithm is like ln?
Yeah, ln x. ln x should be your first choice.
Okay.
I is inverse trig functions, and we haven't done anything with inverse trig functions yet, but we're going to. Inverse trig functions. And inverse trig functions are arcsine and arccosines. So logarithmic, inverse trig functions. Yep. A is algebraic functions, which is like x squared, 2x, 3x, stuff like that. T is plain old trig functions.
These trig functions are really easy.
No. It's because they get weird when you start using them for u, so they're one of the last things you want to use for u. And then
Like what?
so trig functions like sine, cosine, or tangent. And then the last thing you want to use for u are exponential functions like e to the x. And these are things, these are the order in which you want to try to choose things to substitute in for u. So, let's not muck around too much in your notes. Let's actually pass out the assignment.
Instead of rehashing what you-
Yeah, let's not even go over number 1. Let's just jump right into the weeds with number 2. I know. We're jumping right into the weeds with number 2 here. I'm excited too. I know. I'm excited too. No, I actually am.
Why?
Because it's new stuff. New stuff is always cool.
I'm seriously concerned though for next semester. Like I feel like we're here now. We still have half the year.
Yeah,
And it's only gonna be
new stuff.
like
Okay, so we've got two pieces here. We've got our x squared, and we've got our ln x. So one of those is u, and one of those is dv. So we got to pick which of them to be u. So now, right, according to our order of which to pick things to be u, we've got an algebraic thing and we've got a logarithmic thing. Algebraic thing is down here, logarithmic thing is up here. So that means that ln x is going to be u. So we're going to say u over here is equal to ln x. That means we need to find du. We also have to find, or say what v is, and that means that dv is x squared dx. All right, so let's fill in the rest of this little like box thing over here that we have to decide. So if u is the ln x, then what's the derivative of the natural log?
1 over x.
1 over x dx, right?
Yep.
So the derivative of the natural log is 1 over x dx. Because the antiderivative of 1 over x is the natural log, right? Okay. Back over here, this is x squared, so we have to do the antiderivative of x squared. X to the third over 3. Okay, cool. Now, over here. Okay, sweet, this is going to work out. Yay. Yay. I like it when things work out. Okay. Over here. We're going to do... I know, I honestly thought it wasn't going to work out for a second. I was afraid it wasn't going to work out. Over here, we're going to do uv minus... So uv is going to be ln x times that. And I'm actually going to do the v first, just because I like having the x first. So I'm going to do x to the third over 3 ln x. So that's uv minus integral of v du. So v is x to the third over 3. And then du is times 1 over x du. Now, in that second integral, what can I do here to make my life easier? Well, not multiply, but like simplify, right?
Yeah, like cross reduce.
Yeah, cross reduce. So like this x to the third and this x here,
Would cross out towards x squared over.
right, so like this third would turn into a 2, and then this x here would just go away. No more x. So I'm left with just like integral x squared over 2. And then this shouldn't be du, this should be dx, sorry. Dx, right? Now, I can actually just plain integrate this, can't I?
Wait, why is it over 2? It's over 3.
Oh, sorry, over 3.
And then it was supposed to just be 1 dx?
Yeah,
Or
yeah. And so, like, I just, like, put it all together. And then all of this over here is still there. X to the third over 3 ln x minus all of that. Now, I can just integrate this part right here, can't I?
No, because it's x to the second and not the third.
Yeah, I can integrate it still, though.
Finding the antiderivative.
Yeah, so I can make this x to the third
Over 9.
over 9. And then add a plus c at the end, because I haven't added a plus c yet. And then x to the third over 3 ln x. And there's my antiderivative of the whole shebang. That's it. That's the answer.
then why did people use this?
Yeah, that's what I'm saying.
Okay. So we're going to start using this in more complicated situations where we're going to need to be able to find the area under more complex curves. I know. I know.
And why did people find the area under complex curves?
So in order to do things like, so I have space on my brain right now. So the only example that's coming to my brain right now is space related. There's like 1,000 other applications. But like, so, rockets, the things that send us to space, because space is awesome. Okay, so the shape of a rocket nozzle is like that.
Yeah.
Okay, the reason that it's shaped like that with this kind of cone here is it needs to have a very specific shape, and in order to find out the equation that has the exact the maximum, I forget what the word is, but the maximum deflection for the side of the cone, the way that you find out what the equation for that is using calculus. And the equation for that is something that's more complicated than something that we've seen yet. Okay. So like your phone wouldn't get cell service without calculus?
Go calculus.
Okay. There's a bunch more applications. It's just I've got space on the brain right now, and that's the only one that's coming to my head. NASA has been talking about like a new type of ion drive that they had thought was previously not possible, but is now potentially possible. So there's an ion drive that NASA had previously thought was impossible, but is now potentially possible. An ion drive, it's a propulsion unit that could potentially move us at near light speeds. So like whoever would travel between our planet and another planet could travel not within their lifetime, of course not, but within within what would appear to their families, because it would have to be like a generation ship. What would appear to their families to only be about like 200 years, but to everybody, because it would be traveling near light speed, everybody else it would seem like, I forget what the math is, but it would be like, 1,000 years or something like back home. It would be, okay, so the faster you travel, the slower time moves for you, because time is relative. And so like the drive that they were creating is an ion drive that allows you to move faster, and the faster you move, closer towards the speed of light, the slower time moves for you relative to everywhere else in the world, or in the universe. Yeah.
So
It
the
also
trip,
works with gravity.
No, they don't. That's awesome.
It
We're
also works with gravity.
we're gonna destroy our planet like real soon here. Yeah, same thing because time and gravity are inextricably linked.
So the closer you get to a black hole, time is
Right.
it slows down.
Well, okay. Yeah. Okay, anyway, back to this. So on part 3, we have x squared, which is an algebraic thing, and we have cosine x, which is a trigonometric thing. So according to our order in which to choose things for u,
X squared.
yeah, we're going to choose x squared for u. So x squared is u, and then what does that make du?
Cosine x. Dx.
So 2x dx, and then dv is cosine x dx, and that means plane v is the antiderivative of cosine x. So
Which is sine x.
sine x. So then we're going to do uv minus the integral of v du. So x squared sine x minus the integral of v, which is sine x, times 2x dx. And I did not do a good enough job on this one because it doesn't go any further, so we have to throw a plus c at the end. And we're done because at the moment we can't go any further with this
Nice.
one. I'm glad that you're pleased that you can't go any further with that one.
Yeah.
I'm glad.
You can't find what the integral with that?
You can, but like not at the, well,
Yeah.
no, you you can. No, wait.
Don't you just need an antiderivative of sine x and then like 2x?
Because they're a product, and I haven't shown you the inverse of the product rule yet.
Oh, okay, that makes sense.
If it was sine x plus x, then yes, you could.
Okay, never mind, let's just keep going.
You know what I mean? Okay. So back here. So you've got t to the third and e to the t.